In 2025, the U.S. Army found itself mired in an equipment crisis. Development projects like the M10 tank failed, drone transformation efforts stalled, the maintenance system teetered on collapse, and overhaul volumes plummeted by 99%. Shackled by short-sighted thinking and entrenched interests, combat effectiveness continued to erode. Reforms addressed symptoms but not root causes, serving as a wake-up call for global military development. In the fall of 2025, the atmosphere in the congressional hearing room on Capitol Hill in Washington, D.C., was so thick you could cut it with a knife. Before the members of the Senate Armed Services Committee lay copies of a special report marked GAO 25108-679, its cover title, Weapon System Sustainment, Multiple Challenges. Impact Ground Vehicle Mission Readiness, smashed like a sledgehammer the image of robust transformation the U.S. Army had cultivated in recent years. Republican Senator Tom Cotton, chairing the hearing, picked up the report. His fingertips skimmed over densely packed data tables as his voice carried unmistakable skepticism. This report shows that among our Army's 11 core ground vehicle types, only one has ever met the 90% mission capability standard. This means that for the past decade, most combat vehicles have been prone to failure at any moment. Secretary of the Army, is this the combat readiness system we've built at a cost of hundreds of billions of dollars? Below the podium, Army Secretary Daniel Driscoll's forehead glistened with sweat as he hesitated to provide a direct response. This document, known externally as the Army Equipment Assessment Report, now served not only as the basis for congressional accountability but also unveiled the deep-seated issues within the established Army equipment system. Behind it all lay a chain reaction of misguided decisions and systemic imbalances. At Redstone Arsenal in Alabama, the tense atmosphere echoed that of Capitol Hill. In April 2025, this facility, the cornerstone of the U.S. Army's light armored force development, should have been bustling with the mass production of M10 Booker light tanks. Instead, only a handful of prototypes stood forlornly in a corner of the factory, dust settling thinly on their covered hulls. Electronic displays in the facility still showed celebratory images from the project's 2023 certification, starkly contrasting with the current desolation. Several camouflage-clad engineers huddled around the vehicle, murmuring in low voices. The ground beneath their feet bore faint tracks left by the vehicle during testing, the only remaining trace of this tank's brief moment of glory. With a combat weight of 42 tons, it has long strayed from the core positioning of a light tank. The original strategic deployment goal of 2 vehicles per C-17 transport has completely fallen through. Now, a single C-17 can only carry 1, making its airlift efficiency indistinguishable from that of the 70-ton M1 main battle tank. An elderly engineer who had been involved in the project from start to finish removed his hard hat, his tone heavy with resignation. More critically, during mobility tests at Camp Bell Airborne Base, its weight directly compromised the load-bearing integrity of 6 out of 11 bridges on the base. How can such equipment be assigned to light forces for rapid deployment? In fact, the engineer's description was no exaggeration. According to an internal U.S. Army test report disclosed in May 2025, the M10 Buck faced far more than just weight issues. Its M35 105mm rifled gun achieves only 450 to 500mm penetration with armor-piercing rounds at 2,000 meters, insufficient against the frontal armor of current main battle tanks and lacking competitiveness even against some advanced light tanks. Furthermore, weight constraints preclude the vehicle from incorporating an active protection system, significantly compromising its survivability on modern battlefields where drones and anti-tank missiles are prevalent. Few could have anticipated that this project, originally designated Mobile Fire Protection and launched in 2015, would conclude a decade later in such an awkward manner. Looking back at the project's origins, the U.S. Army's vision was understandable. Since the retirement of the M551 Sheridan light tank in the 1990s, infantry units had long lacked close ground fire support. relying solely on air support and suffering greatly reduced operational flexibility in complex terrain. With the emergence of the multi-domain operations concept, the U.S. military urgently needed a light tank capable of rapid deployment. The plan called for producing 500 units by 2035 to equip 12 independent light tank battalions, initially setting a combat weight limit of just 35 tons. However, during development, the Army continuously added technical requirements, first demanding enhanced protection, then increased firepower, ultimately causing the vehicle's weight to spiral out of control, surging from 35 tons to 42 tons. More critically, the project's protracted development cycle caused the vehicle to miss the window of transformation in battlefield dynamics. Following the outbreak of the Russia-Ukraine conflict in 2022, the widespread deployment of unmanned systems and advanced anti-armor weapons fundamentally altered ground combat patterns, drastically worsening the operational environment for tanks and armored vehicles. The M10 Booker remained rooted in traditional ground combat paradigms, inevitably facing the predicament of being obsolete upon deployment. On April 30, 2025, the U.S. Department of Defense issued a memorandum titled Army Transformation and Acquisition Reform, formally terminating the M10 Booker light tank project. This decision came just 10 months after the first batch of 24 vehicles was delivered to the 82nd Airborne Division for trial deployment. This development project, costing over $3 billion, concluded hastily under the banner of strategic loss prevention, yet the underlying chaos in equipment development decision-making remains far from resolved. The Wall Street Journal commented that the M10's termination epitomizes the U.S. military's recurring demand fluctuations and technical specifications divorced from battlefield realities, problems present to varying degrees in multiple Army equipment development programs. The M10 Booker's quiet exit represents merely the tip of the iceberg in the U.S. Army's equipment development challenges. At Fort Carson Training Base in Colorado, the testing site for the RCV remote-controlled vehicle also lies dormant. This highly anticipated unmanned system was once seen as the cornerstone of the Army's manned-in-manned teaming transformation. The initial vision involved developing 3 unmanned combat vehicles of different weight classes to operate alongside soldiers in reconnaissance, assault, and resupply missions, forming an efficient combat system. However, since its launch in 2020, the project has remained stuck in the technical iteration phase. The timeline for mass deployment has been pushed back from the initial 2023 target to 2026, a full 3-year delay. The U.S. Army's 2025 Equipment Development Report indicates that the RCV program has only completed basic testing for the light variant. Testing for the medium and heavy variants has been repeatedly suspended due to issues like power system failures and unstable collaborative control software. More critically, project costs continue to exceed estimates. By June 2025, cumulative spending had reached $2.8 billion, a 40% increase over the initial budget, yet core technological bottlenecks remain unresolved. At the testing site, a technician responsible for data recording admitted that the RCV's cooperative control system frequently experiences signal interruptions in complex electromagnetic environments, preventing it from accurately responding to soldier commands. Not only is it difficult to function effectively, but it may also disrupt combat rhythms, he noted. Notably, the RCV project's challenges are not isolated. Multiple unmanned systems developed by the U.S. Army in recent years have faced similar issues. For instance, the Future Tactical UAV System project intended to replace the RQ-7 Shadow drone has been delayed twice due to sensors failing to meet accuracy standards and endurance falling short of expectations. Meanwhile, the MQEC drone upgrade project encountered software compatibility issues, rendering the upgraded equipment unable to seamlessly integrate with existing command systems and significantly diminishing its operational effectiveness. The development challenges for aerial systems are even more pronounced than those for ground equipment. At Fort Hood, Texas, Several AH-64 Apache attack helicopters sit covered in dust-proof tarps on the helipad. Their serial numbers indicate these combat aircraft have been parked here for over half a year. Nearby maintenance manuals bear repeatedly circled annotations of insufficient survivability, accompanied by combat damage. Analysis reports from the Russia-Ukraine conflict. These documents reveal multiple U.S.-made helicopters were downed by man-portable air defense systems, manpads, and drones, exposing the inherent vulnerability of traditional helicopters in modern battlefield environments. Army halted multiple new helicopter development programs in early 2025, including the Future Attack Reconnaissance Helicopter project intended to replace the Apache. Resources were redirected toward unmanned aerial systems UAS, aiming to mitigate risks by replacing manned aircraft with unmanned ones. However, this abrupt pivot has encountered significant challenges. According to the Army's FY 2025 budget request, it plans to invest $3 billion in developing counter-drone systems while equipping each combat division with approximately 1,000 drones for reconnaissance, logistics, and strike missions. This initiative, dubbed the Army Transformation Initiative, is projected to cost $36 billion over the next 5 years. To fund this initiative, the Army has had to cut back on traditional equipment procurement, including halting purchases of Humvees and Joint Light Tactical Vehicles, phasing out some aging Apache helicopters, and even reducing civilian staffing levels. However, a significant gap exists between ambition and reality. A May 2025 report by the Wall Street Journal revealed that tests at the Bavarian training ground in Germany showed while the concentrated use of large numbers of drones enhanced battlefield awareness, it also introduced new challenges such as command confusion and heightened electromagnetic interference. More critically, the shortage of drone operators has become increasingly acute. Despite intensified recruitment and training efforts, the Army still faced a deficit of approximately 2,000 personnel as of September 2025. After observing the tests, former Deputy Chief of Staff of the U.S. Army Jack Keane candidly remarked, "Land warfare has transformed into drone warfare, but we're not ready. We have numerical targets, but we haven't resolved a series of supporting issues like coordination, logistics, and personnel." If equipment development challenges represent growing pains, then the severe issues within the maintenance system constitute a deep-seated weakness. The Army Ordnance Depot in Georgia, serving as the U.S. Army's core facility for heavy equipment maintenance, most vividly illustrates the gravity of this problem. In July 2025, visitors to this century-old facility encountered a scene starkly at odds with its core base status. The vast overhaul workshop was sparsely populated, with only a handful of technicians at work. Most repair stations lay idle, their floors littered with dismantled, aged components whose rusted metal surfaces gleamed with a dull sheen. On the workshop's electronic display, 2 striking sets of figures scrolled. During fiscal year 2015, the facility completed 1,278 major overhauls of heavy equipment. By fiscal year 2024, that number had plummeted to just 12, a staggering 99% decline. Back then, the workshop hummed with machinery, overhauling at least 2 heavy vehicles daily. Now, we might not get a single overhaul job in a week, lamented veteran technician John Wilson, who had spent 32 years at the depot. Pointing to a row of retired M10 main battle tanks, he added, "These tanks, meant for dismantling and recycling, now sit idle," remarked John Wilson, a veteran technician with 32 years at the armory. Pointing to a row of retired M10 main battle tanks, he added, "These tanks, meant for dismantling and recycling, have become spare parts stations. We've had to strip them for components to repair active-duty equipment, a stopgap approach that's lasted over 3 years." Wilson's observations are corroborated by a GAO report. The report explicitly states that the U.S. Army is sustaining active-duty equipment by dismantling parts from retired or stored vehicles. While this emergency approach temporarily alleviates parts shortages, It significantly compromises the reliability of active duty equipment. The used, aged parts themselves suffer from wear and deterioration, making them highly prone to causing new failures. More concerning is that this maintenance practice is not isolated but widespread across Army depots. From Schofield Barracks in Hawaii to Camp Baumhard in Germany, scraping old parts to repair new ones has become routine for maintenance crews. Underlying this emergency support model is a vicious cycle of abnormally soaring maintenance costs and misallocated resources. Data from the GAO report indicates that among 11 evaluated Army vehicle types, 9 experienced varying degrees of increase in total maintenance costs compared to FY 2015. The M1 Abrams main battle tank saw the most significant maintenance cost surge, with fiscal year 2023 maintenance costs increasing by approximately $180 million compared to fiscal year 2015. The average maintenance cost per vehicle surged from $280,000 in 2015 to $550,000 in 2023, nearly doubling. More concerning is that these rising costs have not translated into improved readiness. Instead, issues like inconsistent parts quality and simplified repair procedures have led to increased equipment failure rates. It's like a 20-year-old car, Wilson explained. You keep spending money on repairs but refuse to replace core components. Ultimately, it just gets more expensive to fix and more prone to breakdowns. He cited the Army's aging M10 armored personnel carrier, which has served over 60 years, far exceeding its original design lifespan. Prolonged service beyond its intended duration has led to frequent component aging and wear issues. However, the manufacturer holding the blueprints for upgraded variants refuses to share them with Army maintenance depots, mandating that equipment be returned to the factory for repairs. Factory repairs are not only costly but also exceptionally time-consuming, with each M113 undergoing major overhauls taking 7 to 9 months, during which the vehicle is completely out of service. During 2025 congressional hearings, U.S. Army Budget Director Bennett disclosed that in FY22 for alone, over 300 M113s remained idle awaiting factory repairs, accounting for 15% of the fleet. Similar situations plague other mainstay equipment like the M2 Bradley infantry fighting vehicle and M109 self-propelled howitzer. Shortages of critical components such as transparent armor and specialized tires prevent timely repairs, leaving vast quantities of equipment idle in barracks. More alarming than the equipment's inoperability is the persistent drain of maintenance personnel, skills, and the deepening talent gap. At the training center of the Georgia Arsenal, observers noted several young mechanics dismantling the transmission of an M1 main battle tank, their process halting and requiring repeated guidance from veteran technicians. Training supervisor Mark Thompson expressed frustration with a sharp decline in major overhaul tasks. Young mechanics lack hands-on experience, leading to slow skill development. Many today aren't even familiar with the M1 tank's transmission structure, let alone troubleshooting complex failures. Previously, we could rapidly train skilled technicians through overhaul participation. Now, with only a handful of overhaul tasks annually, skill transfer has become problematic. To maintain maintenance team proficiency, the U.S. military has resorted to an emergency measure, deploying technicians to service foreign military equipment. A GAO report reveals that during FY 2023 to 2024, U.S. Army maintenance personnel significantly increased overhauls of foreign counterparts' similar equipment, marking a 60% rise compared to FY 2021 to 2022. It's like surgeons in the hospital. If they don't perform surgeries for long periods, their skills will inevitably deteriorate. They can only maintain proficiency by participating in external procedures, Thompson admitted. While this model of honing maintenance capabilities through external assignments temporarily alleviates skill degradation, it also exposes serious flaws in the U.S. military's internal equipment maintenance system. More critically, personnel shortages in maintenance positions are becoming increasingly acute. In March 2025, U.S. military insiders revealed that the Army's logistics and maintenance positions currently face an 8,000-person shortfall, accounting for 22% of all such roles. Due to the demanding nature of maintenance work, average compensation, and limited career advancement opportunities, it is difficult to attract young people to join. Widening the talent gap, U.S. Defense Secretary Peter Hegseth warned in an internal meeting that if the shortage of maintenance personnel and skill degradation are not addressed promptly, the U.S. Army's equipment maintenance capabilities could experience a severe decline within the next 3 to 5 years. Chaotic equipment development and severe deficiencies in the maintenance system ultimately stem from the dual influence of short-sighted development thinking and entrenched interests. From a short-sighted perspective, the U.S. Army has fallen into the trap of prioritizing procurement over maintenance in recent years. In pursuit of short-term political achievements, the military has poured substantial resources into new equipment R&D and procurement while continuously cutting maintenance budgets. The U.S. Army's FY 2025 defense budget request reveals stark resource imbalance: $13 billion allocated for weapon modernization, yet only $27.9 billion for ground and air training plus equipment maintenance, less than 30% of the procurement and R&D budget. This imbalance directly prioritizes maintenance cuts, leading to drastically reduced overhaul frequencies and severe technician shortages. More critically, this short-sighted mindset manifests in frequent shifts in operational concepts. From multi-domain warfare to omni-domain integrated operations, and now to drone first, the U.S. Army has repeatedly adjusted its core combat doctrine within just a few years. This has caused frequent shifts in equipment development priorities, with many projects being abandoned midway or undergoing major revisions shortly after launch due to concept changes. The weight issues plaguing the M10 Booker light tank project are closely tied to the continuous addition of technical specifications following combat doctrine revisions. Underlying this short-sightedness is the influence of industry interests. Major defense contractors have gained dominant market positions in critical military equipment sectors through mergers and acquisitions. These firms prioritize high-profit new development projects while underinvesting in low-margin production of existing equipment components and maintenance services. The GAO report explicitly states that all 18 types of land combat equipment, including both Army and Marine Corps systems evaluated, lacked access to the latest technical documentation or equipment blueprints, with most such data controlled by the relevant corporations. By monopolizing core technical data, these companies force the U.S. military to rely on original manufacturer services for equipment maintenance, thereby securing substantial profits. According to the National Interest magazine, a company's quote for overhauling the M1 main battle tank engine was 3 times that of a third-party maintenance provider. Yet the Army, lacking technical documentation, could not opt for third-party services and was forced to accept the inflated costs. This maintenance model not only inflates upkeep expenses but also exacerbates parts shortages, creating a vicious cycle, driven by both short-sighted thinking and entrenched profit structures. The U.S. Army's equipment system has 陷入 a vicious cycle where new equipment is underutilized and old equipment remains unrepaired. The most immediate consequence of this cycle is a significant weakening of large-scale ground combat capabilities. The core conclusion of the GAO report explicitly states, inadequate equipment mission capability rates have become a critical shortfall constraining the U.S. military's large-scale ground combat capabilities. A set of data in the report speaks volumes. Over the past decade, among 11 evaluated ground vehicle types in the U.S. Army, only the Bradley infantry fighting vehicle achieved a 90% readiness rate for 6 combat vehicle types, while the remaining 5 never met standards. For 5 support vehicle types, readiness rates averaged around 20%. The U.S. Marine Corps faced even graver conditions, with 5 out of 7 evaluated ground vehicle types experiencing continuous readiness declines over the decade. For a modern combined arms army, the risks underlying these figures are incalculable. A combined arms brigade comprises dozens of specialized vehicle platforms and dozens of military specialties. The accompanying ammunition, spare parts, and maintenance standards form a complex system, with support vehicles typically outnumbering combat vehicles. Insufficient mission capability rates for any core vehicle type could disrupt the entire combined arms operational system. For instance, the M88 Armored Recovery Vehicle serving as the battlefield sustainment vehicle for heavy armored forces saw its mission capability rate plummet by 45% over a decade. This means that during high-intensity combat, numerous damaged M1 main battle tanks would lack timely recovery and repair, forcing their abandonment and thereby undermining the entire armored cluster's combat effectiveness. In December 2025, the U.S. Army conducted a large-scale combined brigade combat team exercise at Fort Irwin National Training Center in California. The results deeply alarmed military leadership. Multiple support vehicle failures repeatedly disrupted fuel and ammunition resupply for the attacking force. What was planned as a 3-day offensive mission took 7 days to barely complete, with casualties far exceeding projections. Meanwhile, advanced equipment from other nations demonstrated superior combat effectiveness on the training grounds. Robust maintenance systems and efficient logistics ensured high readiness for their combined arms forces, a stark contrast. This divergence stems from differing development philosophies. The former prioritizes short-term political achievements and corporate profits while neglecting foundational support. The latter emphasizes systematic development and whole-life cycle management of equipment. Facing increasingly severe equipment challenges, the U.S. Army has not remained idle. Launched in early 2025, the Army Transformation Initiative seeks to improve the situation through large-scale deployment of drones and reductions in traditional equipment. The Army plans to equip each combat division with approximately 1,000 drones, invest $3 billion in developing counter-drone systems, and strengthen electronic warfare capabilities. Furthermore, the Army is exploring new technologies to enhance maintenance capabilities. For instance, it is adopting the Navy's augmented reality maintenance system ARMS, enabling technicians to connect remotely with area specialists via AR devices for precise repairs. Simultaneously, it is investigating the deployment of metal cold spray 3D printing devices to the front lines for rapid component manufacturing. The U.S. military has even set a target to reduce equipment repair time to under 4 hours by 2028, aiming to boost battlefield sustainment capabilities. However, these reform measures have faced significant controversy and obstacles from the outset. The primary challenge is funding allocation. The $36 billion transformation budget must be secured by cutting traditional equipment procurement and civilian staffing levels. This has sparked fierce opposition from traditional defense contractors and some military personnel, while partisan divisions within Congress add uncertainty to budget approval. Second, the maturity of technologies like AR maintenance systems and frontline 3D printing remains in the testing phase, raising doubts about their scalability and effectiveness. More critically, these reforms fail to address the root cause: the dual influence of short-term thinking and entrenched interests. As long as the military prioritizes immediate performance metrics and the market dominance of relevant companies persists, fundamental solutions to chaotic equipment development and skyrocketing maintenance costs remain elusive. As noted in a November 2025 commentary by Foreign Policy magazine, the U.S. Army's transformation reforms address symptoms rather than root causes. Without breaking free from entrenched interests and embracing a long-term development philosophy, even substantial technological investments cannot fundamentally improve the equipment system's predicament. This equipment crisis did not emerge overnight and cannot be resolved quickly. It reflects multiple systemic issues: strategic imbalance in U.S. military planning, hollowing out of industrial foundations, and entrenched vested interests. When a military neglects fundamental support systems and treats advanced concepts as mere window dressing, its combat effectiveness inevitably declines. The U.S. Army of 2025 stands at this crossroads. Will it stagnate under the influence of short-sighted thinking and entrenched interests? Or will it undergo profound reform after bitter reflection? Choosing the former means its large-scale ground combat capabilities will continue to decline, further altering its global military influence. Choosing the latter requires breaking through layers of vested interest barriers, demanding enormous political and economic costs. Regardless, the equipment assessment documents from 2025 will become an inescapable chapter in the U.S. Army's history, and its choices will directly determine its future position on the global military stage. Notably, the U.S. Army's equipment predicament offers profound lessons for other nations. A powerful military requires not only advanced equipment but also a comprehensive maintenance system, scientific development concepts, and a healthy balance of interests. Neglecting any single element risks severe operational failures. In today's rapidly evolving modern warfare landscape, only through systematic development and a long-term perspective can truly combat-ready armed forces be forged.